5, 4, 3, 2, 1.
Hi guys, I'm Juhan and Anil today, and we're going to talk about an Ohm's law. Ohm's law is one of the most well-known and one of the most important equations existing in physics world this day. And it's simply V equal IR, and we're going to just talk about each part real quick. V is a voltage, and it's measured by volts, and it's simply energy over charge, meaning it's an energy required to move a positive charge from a negative potential to positive potential. I is current, and it's amperes. It's measured in amperes, and current is a charge over time, meaning it's a rate of flow of the charge. It's a rate of flow of electric charge past the point. Resistance, which is calculated by ohms. Resistors are simply used to convert voltage to current and vice versa. So basically what resistance do is making I proportional to voltage. And that's Ohm's law.
Hey guys, Juhan just talked about the Ohm's law, and we're going to continue explaining it. I'm just going to give you guys a little analogy, something that you can relate it into real life to understand the Ohm's law better. So let's say we have a flowing river with lots of water in it, and we have a big stone in the river. So in terms of the Ohm's law and its elements, the water of the river actually will be current, because it actually kind of mentions us the electrons moving from one way to another. In this case, that will be positive to negative. We can actually consider the stone as a resistance, and the voltage is actually how the water goes from one way to another. So we have the stone as a resistance, and then when we make the stone bigger, if we have a bigger stone, the water is going to have a more difficult time flowing through, and that's going to decrease our current. Bigger resistance is going to decrease our current, and voltage has to equal these current times resistance. And in the other case, if you have a smaller stone, we're going to have more water flowing through. That's going to still equal the same amount of voltage, because we didn't change the voltage. In the equation, that's how we explain it. And during the electrical system, voltage will stay the same because we never touch the battery, but we kind of change the resistance, and therefore the current changes too.
Ohm's law is named after the physicist George Ohm. He was born in the Bavaria state of Germany in 1789. When he learned about the Ørsted's electromagnetism discovery, he began experimenting with electricity, where he discovered what is known as Ohm's law. In 1825, he published a paper that explains the decrease in electromagnetic force around a wire as the wire's length is increased. This was the fundamental of today's Ohm law. In the first diagram of the photograph, we have one battery and one bulb, which leads us to 0.5 amps. In the second circuit, when we add another battery, so we keep the resistance same but increase the voltage, which leads us to more current. In the third diagram, more voltage and same resistance leads us to even more current. In the fourth diagram, though, we only have one battery and 3 bulbs, which leads to a lot of resistance but less voltage, which leads us to very little current. In the fifth and sixth diagram, though, we increase the voltage and keep the resistance same, so the current starts to increase. In the seventh diagram, we have 3 batteries and 3 bulbs, and we start at where we finish, like the first circuit.